the limit as x goes to a of g of x of m, and the limit as x goes to a of g of the sum is
L plus M.
L plus m. So the limit of the sum is the sum between them, right? So that's a pretty intuitive thing, right? I mean, you know, and in calculus, you can try to prove that to you. They say, well, you know, this one's going to L, I'm going to M, so this one's going to L plus M, okay? All right. But what do we try to prove that with this definition? All right, well, let's imagine we've gone back to the wire back to the Math Institute, and let's think about this sort of. So Mr. Epsilon, what happened was, okay, you did a whole bunch of proving the limit of x squared is 4 and stuff, and already you did that so well they immediately promoted you to a super. Isn't that great? So now, you're told, Mr. Epsilon tells you that one of the employees, Frank, also named Frank by coincidence, has proved this. Another employee named George has proved that. And he wants you to show this, right? And so, well, you say, gee, this sounds really familiar, right? It's something very similar in the wire company, right? So the first thing you would say is, well, okay, I think we better call in Frank and George because I have to ask both of them questions, right? The wire company had Frank sitting here and George sitting there. We had to get them to give us all this knowledge about stuff, right? But, so Mr. Epsilon says, well, unfortunately they're both out of the country and they're going to be gone for a month. Go ahead, anyway. Okay? So you see, I'm just trying to say there's a little difference here in the Math Institute, okay? In the wire company, you actually had to find the delta, right? Here in the Math Institute, Mr. Epsilon is not really so interested in the delta as you're proving that it exists, okay? He wants to see your plans. He doesn't want to, in the wire company, all they cared about was, you know, here's your wires, and they probably wanted to guarantee, okay, some warranty or something that it was fine. And they don't care about the plans, right? They just want you to guarantee it, right? But the Math Institute, no, Mr. Epsilon doesn't really care that much what delta is, okay? In this case, he's not going to find out because Frank and George are out of the country, as I said. So he wants to see the plans. How are you going to go find the delta, right? So. What's his question? He wants you to prove this, right? Say you were to give me a tolerance epsilon, could you prove to me that back to the definition. Could you prove he's giving you a tolerance and wants to prove to you that if
F of x plus g of x is tolerably close to L plus M.
could you prove to me that if
If x equals L, G of x.
oh, okay, now give me the proof. If x is close enough, I'm sorry,
Right.
but unequal to a. All right. So Frank and George are gone. But what what would you ask them if they were here? Okay, if Frank and George were here, what would you do? First I'd ask Frank,
How close does x have to be to a for f of x to be close enough at all?
how close you need it? Epsilon over 2, right? And we have at the top, very close. Okay. That means throw this button into the tape, right? Because it doesn't matter. Okay, and so let's say Frank says, if Frank were here, he would give you some number. Okay, delta 1, and similarly, or what? How close? So we'll ask George how close is x to be to a, but equal to a for d of x to be very close. M, and so George says finally delta 2, and then finally this represents, and then u, then I let delta be what? No. Frank gave you the delta 1. George gave you the delta 2. What are you going to do with them? Take the minimum, right? The small one. Okay, well that's basically the outline of the proof. We haven't got time to write that up formally, but we can sort of, we'll do that next time. All right, thank you. Nobody needs handouts? Somebody else.